This is the waves required practical. And what we're doing this time is we're observing the properties of waves in liquids and solids, right? Because what tends to happen is people tend to think about the liquids one because it kind of looks quite cool, right? And then forget about the solids one, right? You've got to be aware of both without any shadow of a doubt. Now, firstly, we'll go for the liquid one, right? So what we're going to do is what you use is a ripple tank. Now, this here is a ripple tank, and it's kind of a bit like that blue plastic is where you put the water in. You've then kind of got a piece of perspex underneath that is sealed to stop the water coming out. This here is a light that then shines down, and this black line here is kind of like a rod that then produces waves. The light, when it shines down, right, so it shines down like that, and what you do then underneath is then you actually see the ripples shining down through here. This black and white diagram kind of explains that exactly again. So we've got our light shines down, and what you then do is then you see your ripples appearing on kind of this white card that's then at the bottom. The black line here, that is then your rod, right? And what the rod does is it makes the waves actually here. Makes the waves appear rather. And you've got a power supply, right? And that power supply then causes vibrations to make the waves happen. And the only thing not mentioned so far is then you've got a meter ruler at the bottom. Now, what I'm going to do is I'm going to kind of go through it and sort of break it up, the methods themselves. So pour water to a depth of about 5 millimeters into the tank, right? So that is then you put your water in there to about 0.5 centimeter. And obviously it needs to be flat, it needs to be all sealed, it needs to be kind of in good working order. Adjust the height of the wooden rod so it just touches the surface of the water. So the wooden rod that we're talking about here is that. All right, so that is then our wooden rod. So it's just touching the surface. Switch on the overhead lamp and the electric motor. So the overhead lamp shines down. This is then our electric motor that then causes the vibrations. Adjust the speed of the motor to produce low frequency waves. Now we want low frequency waves so that they're easier to see and they're easier to count. Now, this at the bottom here is kind of the thing that you'll see. And what I'll do is I'll just talk about that in a minute, just to work out the wavelength. So 50 centimeters, 1, 2, 3, 4, 5 waves. So the wavelength is 10 centimeters. And again, if you do it in a meter, you'll have more kind of ability to work out the wavelength. Then what you've got to do is you've got to count the number of waves passing a point in the pattern over a given point for 10 seconds. So what you do is you choose a point, and you can sort of see these waves moving, right? You've then got to count the number of waves that go past that point in 10 seconds. Right, so literally what you'll do is you'll look at the waves and you'll see 1, 2, 3, 4, 5. And what that does, it gives you the frequency. And what the frequency is waves per second. Right, so if you do it for 10 seconds and you see 20 waves, the wave frequency is half, because it's a half a wave per second. Then what you do is you calculate the speed. Calculate the speed of the waves using the equation wave speed equals frequency times wavelength. We've got frequency from our meter ruler, we've got wavelength by our counting. Then I've just then written out the equation here, so wave speed in meters per second, frequency in hertz, which is waves per second, and wavelength in meters. There's the formula, and then this is an example. There's a frequency, there's a wavelength, and there's a speed. Now, something I didn't mention before is I actually said that the wavelength was 10 centimeters, where obviously what you've got to do is you've got to convert it to meters, so it would be 0.1 meters. Now, the second one, and then this is the one that people tend to forget about, is looking at waves in a solid. All right, so I've then got here is I've got a vibration generator. Right, so what it does is it attaches to this string here. So this is a piece of string, right? And it's got a set of masses down at the bottom there. That vibration generator is attached to the string. It's a bit like a guitar. You know, when you strum a guitar, then the string vibrates, right? But what this is doing, the vibration generator is doing constant vibrations. The piece of string, set of 100 gram masses or hangers, set of 10 gram masses and hangers, they are then to hang off this end here. A wooden bridge, which is this here, which is a bit kind of like there's like a wooden bridge on a guitar, and then a pulley on a clamp. So this pulley here is just to allow things to kind of move if you need them to, so it's not really fixed in place. The method. So what we've got to do with this is you switch on the vibration generator, right, which is actually, I think it's behind here now, right, the diagram's kind of moved a little bit. Then what you've got to do is you've got to look to see a clear wave pattern. So you adjust the vibration wave pattern until you see the wave. And really the wave should look like it's not even moving. It almost looks like it's kind of frozen in time. Use a meter ruler to observe across as many half wavelengths as possible. Then divide by the total length of the number of half waves and multiply this by to give 2 wavelengths. Now, what I'm saying there is how many half wavelengths can you see? Okay, you've then got to work out literally the wavelength from there to there. So if you can see a full wavelength, then what you can do is you can just measure that wavelength, right? Or if it's a little bit more complicated and there's more, right, then what you can do is you can then work out the number of half wavelengths, double it, and then divide by the number of full wavelengths there is. The frequency of the wave is the frequency of the signal generator. All right, so where you got the signal generator down here, what that will then do is that will then produce a frequency. You then calculate the speed of the wave using the equation wave speed equals frequency times wavelength, and then you can then get your wave speed in the solid. You could also repeat it, change the frequency on the actual device itself, right, and then do it for different frequencies and see what wave speed you get. This is then examples of some results. I've got 100 gram mass hanger, right? My frequency is 5, 10 and 15. That is then from my frequency generator. I've then worked out my wavelength in meters. Okay, so whether it's in a meter ruler or however it is actually worked out, I can then work out my speed. Right, but what you'll actually see is when you're actually setting this up, you will see the wave itself. And you've got to, depending on how it's set up, you've got to work out from a peak to a peak, a trough to a trough, and work out the wavelength. Wave speed equals frequency times wavelength. You use that calculation or formula rather to work out the speed in meters per second. Right, so what you've got there is you've got 2 practicals. Okay, but the most important part of it now is how do you work out the frequency of each one, and how do you work out the wavelength? So if you listen to that and you're a little bit unsure, go back over the video again, right, and make sure you can see how you work out the frequency for both of them and how you work out the wavelength for both of them, right? Because what you're doing then is you're using that equation that then is provided to calculate the wave speed, and that'll be kind of the culmination of the practical itself.